Good morning, grade 11. Now, inshallah, we are going to complete the previous sessions that we started before, which is called instantaneous reaction rates and reaction mechanism. Okay, listen, please.
Section 4, Instantaneous Reaction Rates and Reaction Mechanisms. The slowest step in a sequence of steps determines the rate of the overall chemical reaction.
So the slowest step in a sequence of steps determines the rate of overall chemical reaction. How? First, the essential questions that we are going to study in this lesson.
Essential questions. How are instantaneous rates of chemical reactions calculated? What substances and steps are involved in a reaction mechanism? How is the instantaneous rate of a complex reaction related to its reaction mechanism?
So this is the questions that you are going to study, inshallah. How are instantaneous rates of chemical reaction calculated? What substance steps are involved in a reaction mechanism? How the instantaneous rate of complex reaction related to its reaction mechanism. Okay, but first the vocab that we studied before, decomposition reaction, and we said before that the meaning of decomposition reaction means that making decomposition or analyzing of the reactants to produce new substance, okay, new substance or new compound with new bonds. So it's called decomposition reaction, okay? But the vocabs that we are going to study, okay, listen please.
New. Instantaneous rate. Complex reaction. Reaction mechanism. Intermediate. Rate determining step.
So the new vocabs that we are going to study, number one, instantaneous rate, complex reaction mechanism, intermediate rate determining step. Okay, so first, according to instantaneous reaction, okay, the figure shows the concentration of H2O2 over time during the decomposition reaction of 2H2O2 aqueous solution. By its decomposition will produce 2H2 plus O2. Okay, so it's the concentration of H2O2, but that decreases by time. Okay, decreases by time. Okay, to produce 2H2O, and O2 evolves up as gas. It's okay. So an instantaneous rate is the slope of the straight line tangent to the curve at specific time. This specific time, as example, so it's a line or tangent to the curve, it's a line, so it's the slope of this line. This is called instantaneous rate. Okay, so after that, according to instantaneous reaction rate, instantaneous rate can be calculated if the concentration are known, the temperature is known also, and the experimentally determined rate law and a specific rate constant at temperature are known. So all this must be known. As example, 2H2O5, a 2N2O5 gas to produce 4NO2 gas plus O2. Rate is K, it's constant. K of N2O5. K equals 1 times 10 power negative 5 second, negative 1, and N2O5 equals 0. 350 mole per liter. So its rate equal 1 times 10 power negative 5 times 0.350 mole equals 3.5 times 10 power negative 6. It's okay. After that, this is a problem. And the following reaction is first order in H2 and second order in NO with a rate constant of 2.90 times 10 power 2 liter square divided by mole square times second. 2NO gas plus H2 gas produce N2O gas plus H2O. Calculate the instantaneous rate when the reactant concentration R NO equals this number, while H2 equals. So after that, the known NO equal H2 equal K constant equal. Unknown is the rate. How can we calculate it? Rate equal K NO2 times H2. So rate equal NO, rate NO 2.90 times 10 power 2, okay, times 0.00200 of NO times 0.00400 times according to H2. So finally will be equal 4.64 times 10 power negative 6 mole per minute. Okay, so this is the answer of this problem. After that, listen please to this.
Reaction mechanisms. A reaction mechanism is the complete sequence of elementary steps that makes up a complex reaction. Most chemical reactions consist of sequences of two or simpler reactions. Each step is called an elementary step. A complex reaction contains two or more elementary steps. An intermediate is a substance produced in one of the elementary steps and consumed in a subsequent elementary step. Intermediates do not appear in the net chemical equation.
Yeah. So it's a reaction mechanism. Reaction mechanism. A reaction mechanism is the complete sequence of elementary steps that makes up a complex reaction. Most chemical reaction consist of what? Consist of sequence of two or more simple reactions. As each step is called an elementary step. And a complex reaction contains two or more elementary steps. An intermediate is a substance produced in one of the elementary steps and consumed in a subsequent elementary step. Intermediate do not appear in the net chemical equation. Others. This is a reaction mechanism. Chlorine catalyzed the composition of ozone. Okay, chlorine is ozone. This is chlorine atom plus ozone gas. And we know that ozone gas consists of three oxygen atoms combined to each other. So chlorine atom make combination with one oxygen atom to produce ClO, and the rest of ozone gas will be oxygen molecule, which equal AO2. So Cl plus O3 produce ClO plus O2. As ozone gas, O3 consists of the reaction between one oxygen atom and one oxygen molecule. And we said before that the difference between oxygen atom and oxygen molecules, that oxygen atom consists of one atom only, while oxygen molecule consists of two oxygen atoms joined to each other. After that, ClO, which is produced from the first equation, plus oxygen only, which free oxygen atom, to produce Cl individually plus O2, oxygen gas again. So this is called intermediate reaction. Okay, intermediate reaction between the first and the last one. Okay, this is chlorine catalyzed decomposition of ozone gas. Okay, after that, the reaction mechanism as 2NO plus H2, its reactants. So it will take an activated complex, then intermediate reaction to N2O2 plus 2H2, then activated complex, produce intermediates again, N2O plus H2O plus H2, then activated complex, and finally will produce product N2 plus 2H2O. So it's a finally of this equation. Final is equation, which equals that, equal what this finally, equal what this finally, 2NO plus 2H2 is the reactant, equal finally N2 plus 2H2O. But all these are called what? Are called activated complex and intermediate. Called what? Called an intermediate reaction. Understand? Okay. Observe this diagram for a while. Okay. So after that, reaction mechanism. Listen, please.
Reaction mechanisms. Every complex reaction has one elementary step that is slower than the others. The slowest elementary step in a complex reaction is called the rate-determining step.
So it's the meaning of what? The meaning of rate determining step. As every complex reaction has one elementary step that's slower than the others, and the slowest elementary step in a complex reaction is called the rate determining step. Okay. After that, the review that essential questions that we studied before in this lesson.
Review. Essential questions. How are instantaneous rates of chemical reactions calculated? What substances and steps are involved in a reaction mechanism? How is the instantaneous rate of a complex reaction related to its reaction mechanism? Vocabulary. Instantaneous rate. Complex reaction. Reaction mechanism. Intermediate. Rate determining step.
So these are vocab and essential questions that we studied in this lesson. Okay, I think that we finished this lesson according to this PowerPoint, and now we are going to go. How can we answer the question about this lesson? Okay. So question number 1. Can you answer it, Hussein? Okay, what quantity is
Yes,
defined
question.
okay, Hussein, can you answer the first question, please?
What quantity is defined as the concentration of a component in a chemical reaction at a specific time?
Yeah, what a quantity is defined as the concentration of a component in a chemical reaction at a specific time. What is this quantity? Specific rate constant, or rate order, or instantaneous rate, or catalyst?
Um, Instantaneous rate.
Instantaneous rate, it's okay. And question number 2, what is the slowest of the elementary steps in complex action called what? Slowest
Rate
elementary
determining step.
rate determining steps. Okay. Question number 3, what is the name given to chemical produced in one elementary step and used up in a subsequent elementary step? Given the chemical produced.
Intermediate.
Intermediate. Okay. In the reaction of hydrogen peroxide, What happens to the instantaneous rate as time passes? What happens to the instantaneous
Decreased.
rate? What?
Decreased.
It decreased. It's okay. The last question, okay, in these reactions that we studied now, okay, what happens? What are the intermediate? Intermediate.
We have two intermediates.
With intermediate, what about A, B, C, or D?
D.
D. Okay. Now we are going to grade this test. Okay. Number one, true. Two, true. Three, true. Four, true. But five, it's N2O2, N2O2, and N2O. Okay, because this is
Why?
gases, because this is water vapor and hydrogen gas that can't be calculated. Okay, because they are water vapor and hydrogen gas. N2O2 and H2O are produced during one step and consumed in that. Okay, produced in one step
Okay.
and do that. Okay. Thanks, Hussein, for your participation. Okay, and I think that we finished this term, Alhamdulillah. Okay, till this module. Okay, this lesson. Okay, that we finished. Okay, which is called instantaneous reaction rate and reaction mechanism. Okay, and inshallah from the next week, inshallah, we are going to make a revision. We are going to make a revision for this lesson and lesson before, according to your schedule that I think our school sent to your WhatsApp. Okay,
Okay.
so we are going to make a revision, inshallah, from the next 2 weeks. Okay, thanks, Hussein, for your participation, and I hope that you enjoyed with our chemistry session with me. Okay, happy Ramadan and enjoy your time.
Thank you.
Okay, thanks, Hussein. Goodbye.